Okay, in this video, in this lesson, we're going to be graphing sine and cosine by hand. So you just had the pleasure of watching me graph sine and cosine from negative 2 pi to positive 2 pi. So in the previous video, we looked at different components of sine and cosine. That would be amplitude and period. So here in this video, we're going to be using those two things to graph the functions. So jumping right away into our problem. So let's say we want to graph y equals sine of 2x. Okay, so let's identify, first of all, to begin with every problem, let's identify the amplitude, as that will most likely be the easiest thing to see. So our amplitude here is 1. So now let's identify the period, the distance needed to complete one cycle. So that would be 2 pi divided by b, as we recall, and b is 2. So our period is a distance of pi, which would make our interval of 0 to pi. Now, our typical interval is from 0 to 2 pi. So because our interval has shortened a little bit, that affects how we're going to graph. So how we're going to do this, we're going to take our interval, we're going to do this actually every time when we look at period. We're going to take our interval and divide it into 4 equal parts. I'm going to explain how we do that. So we're going to have this table. Every problem we graph, we're going to have a table where the top row is our x. Now, we begin with 0. Okay, so doing this. When I'm making my table, I have 4 lines, and then that lets me know when my table is going to be done. So I have 4 lines in the center here, making 1, 2, 3, 4, 5 regions. Now, yes, it said 4 equal parts. And you'll see how we're going to have 4 equal parts having 5 blocks. So 0 pi. Now, to find these parts, how we do this is to find the exact middle, we take the midpoint of these two. So that is 0 plus pi, and we multiply that by 1/2. Okay, now we're going to do some of this mentally. So that's pi times 1/2 is just pi over 2. So then we think, okay, the next section. So now I take 0 plus pi over 2 and divide that by 2. That would give us pi over 4. And then pi over 2 plus pi, that would be 3 pi over 2 divided by 2, or just 3 pi over 4. So literally, in this case, since we were with 1 pi, we see that we're in quarters here. So we have 1 region, 2, 3, 4. So we're looking at the areas between them. That's about 4 equal parts. So we have that. We separated our interval. So we're going to relate this back. We're going to write 2x here. So 2x is, that's what we have in this, and you'll see why. So if I multiply x by 2, we get 0. If I multiply pi over 4 by 2, we get pi over 2. If I multiply pi over 2 by 2, we get pi. 3 pi over 4 by 2, we get 3 pi over 2, and we get 2 pi. So the purpose of doing that is we need to know the y values to plot. So we know what our x values are here, cutting into 4 equal parts, but what are the y values? So now I've related this back to values I should know, pi over 2 pi, 3 or pi over 2, and 2 pi. So now I'm going to take the sine of 2 pi. I'm just taking the sine of my previous row. Sine of 0 I know is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So in doing that, and using this center row, I now know that with x of 0, our graph is at 0. Pi over 4, we're at 1. Pi over 2, we're at 0. So let's see what we can do here with our graph. Now, with our graphs, something with scaling, we're all, at least I'm going to have four blocks to get to +1, okay? And then same on the other side. So right here would be -1. And every 3 is a half pi. So pi/2, because we went pi/6, pi/3, pi/2. And then keep going in sixths, we get to pi. And then keep going in 6, we get to 3 pi/2, and we get to 2 pi. Now you might say, wasn't our interval only to pi? Well, yes. And you're going to see why I wrote all the way out to 2 pi. So to graph this, we have these 4 values. I am also going to, if I need to in a different color, you can do that. And I'm going to be doing this here. So pi/4 is midway here. And that's one of my values. I'm going to circle that. Pi/2, already have, I'm going to circle that. 3 pi/4 is it's halfway within this interval. And then pi. Okay, circling it gives me a better visual of where to exactly put my points. Otherwise, it might get a little cluttered here with all the markings. So at 0 now. At 0, sine of 2, this should be 2x, oh my goodness. Probably wondering what was going with 2 pi there. Sine of 2x. So at sine of 2x, where x is 0, we're at 0. At x of pi/4, we're at 1. At pi/2, we're at 0. At 3 pi/4, we're at -1. And at pi/4, we're at 0. So we have less points here to make our graph more defined, but we know by now at least what our graph should look like. Okay, now I'm going to extend this just into 2 pi. So let's extend it. So here we're back up.
If anyone has not submitted grades at this time, please do so. We're double checking all grades now. Ms. Melissa, we need to make sure that all grades are submitted at this time. Thank you.
Then we're going back down to -1 and then to 2 pi. So continuing it. Okay, the reason why I went out to 2 pi still is I have this tracing paper that I laid out sine of x. Now the reason why with this whole scaling we did with 4 spaces is that's what was used here. So you can see how the period of pi, it took 2 pi for the original to get to 1 cycle. Here it only took the graph to pi to get 1 full cycle in. So within that 2 pi range, it got 2 full cycles in. And that's actually a concept called frequency. To get 2 full cycles within 2 pi, it's frequency. But you can see how it compares to the basic sine function. So let's try another. So let's graph the function y equals cosine of 2/3 x. Okay, so 2/3 x. So amplitude of 1, great. Period. So our period b is 2/3, 2 pi over b is 2/3. So when I divide by 2/3, it's actually multiplying by 3/2, which makes it 6 pi over 2, which makes it 3 pi. Ooh, so we have a stretch here out. So our interval is from 0 to 3 pi. And we're dealing with cosines. We're going to get a good picture here of the cosine graph. So making our table, so having x, so it's 0 to 3 pi. So think our middle here, 0 plus 3 pi divided by 2, 3 pi over 2. Okay, so 0 plus 3 pi over 2 divided by 2 be 3 pi over 4. Notice how I'm just simply multiplying the bottom by 2 here. So 3 pi over 2 plus 3 pi, that would be 3 pi over 2 plus 6 pi over 2, which is 9 pi over 2. So 9 pi over 2 divided by 2 is 9 pi over 4. Okay, so that's going to require some mental math. If you need to write that down, it would look like this. 3 pi over 2 plus, again, I would say this is 6 pi over 2. So there's the 9 pi over 2, and I'm multiplying that by 1/2. Okay, so doing that, I'm going to write here 2/3 x. If we do this right, this row should be the same every time we do this. With every problem, this row should be the same. So 2/3 times 0 is 0. 2/3 times this, the 3's cancel, we get 2/4, which is just pi over 2. 3/2 times 2/3 is 1, so just pi. 9/4 times 2/3, that's 18/12, which simplifies to 9/6, which simplifies to 3 pi over 2. And then 2/3 of 3 pi, the 3's canceled, giving us just 2 pi. Again, the same as the first example. It's a common thing, okay? And it's important because it helps us evaluate exactly what our function is. So when I want to know what our value is at our top row, our essentially new period, I'm going to use this middle row to help me. So cosine of 2 pi over 3 is actually cosine of this. So cosine of 0 is positive 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0, just like pi over 2. And cosine of 2 pi is back to 1. All right, so let's make our graph. So again, 4 above and 4 below the x-axis. Okay. Notice how I'm not really using the negative x values just because our period doesn't require it. So I am always going to be doing with my scaling the pi over 2, pi, 3 pi over 2, 2 pi. Okay? Because that will allow me to get a good visual of how it would compare to the original cosine graph. Now notice, I need to go out even further. So that would take me to, another pi over 2, that's 4 pi over 2, that's 5 pi over 2, and then to 3 pi. Okay? So there, I needed to go past it. So, let's see, 3 pi over 4, that's actually halfway between pi over 2 and pi, so it's right here. I said pi over 2, pi over 4. 3 pi over 2, we already have that. 9 pi over 4 is just past 2 pi, so 9 pi over 4. I know that because 2 pi is 8 over 4 pi, so just past it. And then 3 pi. All right, and 0 obviously. So at 0, cosine's at 1. At 3 pi over 4, at 0. And then we're done following this pattern. Let's write this. it's periodic, so I can really, once I get started, I can just follow the pattern. All right, so connecting. And there's our graph, at least from 0 to 3 pi. So the cosine, I have a tracing paper for cosine. So the typical cosine of x requires only 2 pi. So you see visually how this graph was extended, was pulled horizontally with that stretch. All right, one more example for this video, for this lesson. Let's go back to using sine. So let's graph f of x equals -2 sine of 3x. Okay, so amplitude of 2. The negative tells us that we are reflecting over the x-axis. If we do our table correctly, this will be done for us actually, just so you know. The table will take care of the reflection for us as well as the amplitude. So period. The interval for one cycle is, let's see, b is 3, so 2 pi over b, or just 2 pi over 3. Okay, so our interval to complete one full cycle is only 2 pi over 3. So it's a lot less than just 2 pi. All right, so let's cut this interval into 4. Let's make another table. All right, so there's 1, 2, 3, 4, and then our last one. All right, so 0, 2 pi over 3. Okay, so our middle one will be 0 plus 2 pi over 3 divided by 2, which would be 2 pi over 6, or just pi over 3. All right, and I'll write the next one down for us. So 0 plus pi over 3, and I want half of that for this. So that'd be pi over 3, half of pi over 3 is pi over 6. Okay, and then I want pi over 3 plus 2/3 pi over 3. I want half of that, so that would be, let's see, 3 pi over 3, which is just pi, so pi over 2. Okay, so now our next row would be 3x. So again, I can just fill this in. 0, pi over 2, pi, 3 pi over 2, 2 pi. So then I would have, I'm not going to jump right away to -2 sine 3x. I'm going to do sine of 3x first. So I'm going to fill that row in. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi, 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So now when I go about doing -2 sine of 3x, I can just take this row and multiply it by -2. So 0, -2, 0, +2, and 0 again. All right, so we have our y values, we have our x values, we can plot these. And let's see, here's 1. Well, let's make this 2 for the sake of space. Plus, we kind of need to make it 2 since our, yeah. So, okay. So, pi over 2, pi, 3 pi over 2, 2 pi. Let's do with that. Okay, so I need to plot pi over 6. That's right here. Pi over 3 is next beside it. Pi over 2. And 2 pi over 3, which is the next one. All right, so at 0, sine's at 0. Pi over 6, we're at -2. So there's, right away we're seeing the reflection. Pi over 3, we're at 0. Then we're back. I can just see the pattern. And then here. And I'm going to continue this all the way out to 2 pi. So we're noticing each space I'm going down, up, down, up. So my next one I know is going to be a 0. Then up here, 0. Down here, 0. Up, down. Something's not right here. Hold on a second, I can find it. Oh, right there. Oh my goodness. Oh my goodness. So, forget this, ladies and gentlemen. Okay. So, we see, and we have in this picture, one period of our graph. And it's only going to 2/3 pi. So, doing this, I was actually going to try to show you. Let me show you what it should look like here. It should look something like this, so you can see how for 2 pi we have 1, 2, 3 complete cycles to get to 2 pi. But when we practice this, and I wish you luck on that, when we practice this, you're only going to be doing 1 full cycle of this. If you want to extend it, you can. It's good practice to do that. But I'm only going to be asking for 1 cycle of it. So I wish you best of luck in the practice. I apologize for the extra dots here, just to make it look pretty, I guess. But in the next video, we're going to add more to this. We're going to be looking at vertical and horizontal shifts.